I'm invading your space. I'm sorry. Let me know if that goes out. All right, guys. Let's make our formula sheet. So I'm gonna make this really, really clear. You can lose points on your formula sheet if you have too much on there. You can't put You can only put the formulas we're about to put on the board on your formula sheet. Anything else basically is open game for me to take points off for. Don't put little marks and stuff. Don't have stuff erased. Don't have stuff scratched out because I don't know when you did that. Right? I don't want you to have an unfair advantage anybody else doesn't have. All right. So this is all I can have. So the whole first chapter is basically definitions. So there's no formulas from there really. And then we get into the next section where we have. You could write the book's formulas down for the percentiles if that's the way you did it. If you did it that way, I'm sorry. I mean, the idea is much simpler than that, so there's no real formulas for that. I think the first formula we really have is like, you need to write that down because you know how to find the average of numbers, right? I think the main formula we want to put down is for the standard deviation. So you can put both of these down. The thing you can't have is words. You can't have population variance. You can't have the word population anywhere on your... What tells you that this is a formula for population? Greek letters. I love it. There's Greek letters in that thing. Or, you can write that formula. You can write this formula. Whichever one you feel more comfortable with. Do you see how they both say the same thing? You can put both of them down there if you want to. You should know yourself and what will confuse you or not confuse you. Obviously, you want to include this one. Or you can put this one, or you can put both of them. Cool, I like it. What's this the formula for? Good. Variance. I think I heard over here. Population variance. I love it. And this is of the sample. I love it. Sample standard deviation. Kick ass. Yes, ma'am.
Can you do the setup for when we do the classes?
Oh yes. Sure. But not on the formula sheet. But we'll do an example like that in a minute.
Okay.
Anything else you want to suggest to go on the formula sheet? Now is the time to suggest it. Yes, ma'am. I like it. IQR?
Yeah.
I don't think the book or I have said this. Yeah, maybe I did. I can't remember now. If I call this a Z-score?
Yeah.
I think I used that word, yes. And I said the book didn't say it yet, but I'm going to say it now because we're freaking dealing with it. Might as well call it what it is. What did the Z-score tell you?
Difference between
That's an S, yeah. Measured in what, though? Don't just say how far away, because I'm going to be a complete jackass and write in miles, question mark, in furlongs, in light years. I'm going to apologize ahead of time. I'm going to be a complete dork if you just say how far it is. I need more, how far it is measured in what? And that's a weird way to say it. Measured in standard deviation. That's one way to say it. Or just how many standard deviations there are from the mean to the data point. Let me stop there for a second. There's actually one more formula that's even nicer. It's somebody help me out. This is the most algebra you'll see in this class. We will do this every now and again where we manipulate variables, but we're about to do it right now. Oh shit. But before I do that, what is this? This is a Z-score for a population or a sample information? Sample, obviously. It's got R letters in it. What's it look like if it's a population? I like it. Please realize those formulas are the same damn formula. X minus whatever your mean is divided by whatever your standard deviation is. That's the formula. It could look like that or that if you had a sample or but it doesn't change. The idea doesn't change. The idea actually never changes. And some of you might not believe me when we get further in the semester, but I'm trying to make believers out of you. Not believers, believers. Is that still a thing? From your non-reaction, I'll say no, thank God. It is? Oh, shit. I mean, oh, okay. In case any of you really like the Beeb. Anything else? Oh, I want to show you this. How do I... Go with me now. Oh, the power of algebra. You guys don't believe. How do I solve this thing for x? Yeah, anytime I have a fraction in an equation, I can multiply by that stupid thing to get rid of the fraction, right? So I can multiply by s and then add x bar. Got it. So what's that say? Start at the mean and go this many z-scores to get to the data point. So what's a z-score? It's the number of these away from the mean to the data point. You can read that equation in English, and it's a note that I allow because it's a formula. So I can't not allow it.
Can we write the equivalent?
Sure.
Population?
So same idea. You multiply by sigma, and then add the mu. So what's the z-score? The number of standard deviations from the mean to the data point. Sorry. That's all right. You can stand if you need to. There you go. Just don't stand in your chair. These chairs, I don't trust them. It'll be a liability issue. Yes?
Could you repeat that one more standard number of?
So let me put these up here. So these are the ones I just added. Yeah, there. I don't know why I put these in reverse order. So the z-score is the number of these from the mean to the data point. How do I get to a data point? I start at the mean and I go this many steps. Bless you. So, for example, all right, this is bless you. Are you maybe allergic to purple? Is that? I'm not allergic. I like it too much. If you ever see a teacher sniffing at it, you gotta worry about it. All right, now. Watch this. This is the formula sheet. This is not. You put this stuff on the formula sheet, you lose points, right? This is an example. And this is straight from the homework, actually. If the mean was 11 and the standard deviation is 2.9, what data point is 3 standard deviations above the mean?
Wait, what?
19.7 plus
How big is each step that I can take? How big is each step? 2.9. Good. How many steps do I want to take? 3 steps. Oh, above what?
11.
Okay, now, what would the math look like to do that?
11 plus 2.9.
Yes, I want to start at 11, and I want to go up
2.9.
3 of these. Isn't that mean plus z sigma? Or I've used mu and s, but oh well.
That's what confused me.
Oh, really? Say that. I didn't do that on purpose. I wasn't even thinking this is what I wanted to get to. Okay.
It's okay.
All I needed was a mean and the standard deviation. That's all I care about. So please let that just make physical sense. If I start here and I take so many steps, and every step I take is so much big, you got to be able to do that math, or else you shouldn't be in this class, right? What's beautiful is let that be easy. And I know when you're in a stats class, you're not sure what's supposed to be easy and what's brand new shit. This is old stuff. We're just now realizing what they all are. We're just giving them names. We're giving them math names for what they are. But the actual computation is, low stuff. Right? So I understand that you're a little like, what the hell's supposed to be easy and what's not easy? Oh, this ain't supposed to be hard. Right? The idea that we just use here. So the book doesn't even use this symbol yet. They just call it number of standard deviations. But I want to tell you that's called a z-score because we got it out there now. So what's up? I'm sorry. Did I skip over something? Are you guys with me on that? So that's where that formula comes from. How do we get to a data point? I start at the mean and I go this many steps. So start at the mean and I go this many steps. So what's the z-score tell you?
How many steps?
How many standard deviations from the mean to the data point? I like it. Kick ass. Why do I make so much of a deal of that? Because every test I give you will have that as a question. I think I told you that already. Can't remember, but if I haven't, there you go. You always want to know what's going to be on the test. I've just told you one question that will be on every single test. I'm going to ask you, I can ask it to you two different ways. I can say, what does the z-score tell you? The number of standard deviations from the mean to the data point. Bam. Or some variation thereof. Don't just put those words down and hope to God understand why they go the order they do. Don't just say, I remember him saying something about mean and standard. Or I could ask you, what would a z-score of negative 1.5 mean? What would the z-score of negative 1.5 mean, knowing what z-score means? That data point is below the mean, be more specific. Negative 1.5 standard deviations below the mean. Bam. If that was your quiz score, that means you scored below average. 1.5 steps below average, right? Okay. So you want a positive z-score if it's your grade. You want a negative z-score if it's your golf score, right? You guys understand what low golf scores? Okay. Cool. Is that cool? Is that understood? All right. So they actually have questions in the book. The book doesn't show it like this. The book puts, instead of z-score, it says number of standard deviations. It actually writes that out, if you guys have seen that. But we know that's a z-score. That's what that z-score means. All right, I like it. Okay. Anything else you think should be on the formula sheet? You see, somebody already made a suggestion, and I agreed. So you never know. Anything I skipped that you think should be on there? I didn't skip anything on purpose. You're like, this is some teacher thing he does. And like, nobody says it. No. All right, cool. So that's the formula sheet. Now, throughout the semester, you can make a brand new sheet. You just bring all your formula sheets with you. I don't care. Have you had a teacher that makes you put it on like a 3x5 card or something? Yeah. Right? And that's just so they can laugh at you as you try to put it on. I'm like, I'll make you put it on a grain of rice. So you have to figure out how to, and then you're like, oh God, what did I say? Just so I can sit there. Like, screw that shit. Just bring as much paper in for you, but it can only be the formulas we talked about. And you can't bother people around you. So don't bring this big giant ass scroll that hits other people in the head. As long as it doesn't annoy anybody else, including me, it's fine. My formula scroll. I like that. All right, maybe. All right. So where do you guys want to go first? Any suggestions on what to talk about?
I don't know how to find the standard distribution or whatever.
Okay. And I remember, let me do this other one first. I just remember somebody had a question about classes for histograms.
Yeah.
Yes? Okay. I knew it was somewhere over there.
I just need to know which way the arrows go.
The arrow? Oh, the inequality symbols.
Yeah. No, can we just talk about all of them?
Classes.
We could just talk about
How to find standard deviations? The table? Okay.
Can we completely go over standard deviations?
Sure. Okay. So let me start with this. All right, here's one type. Well, let me do classes real quick. Let me just get that looked at. How do you find the class width? A lot of you guys were just telling me The class width is 10, obviously.
High minus
I need something.
divided.
Yeah. So high. So the width is high minus low divided by the number of classes.
I thought that's what it
Say again. And the reason that makes sense, why does the standard deviation formula make sense? Because it's how many of these fit into this. That's really what that is. When you divide, you're figuring how many of the thing at the bottom fits into the thing on the top. That's why 6 divided by 2 is 3, because 3 2's fit into 6. Really interesting way to look at it, but that's what it means, right? So what is this formula saying? How many, how many of these, how big do these have to be? This is how many steps. This is actually the reverse. This is how big do they have to be so that this many fit into there.
So you just pick that number, the number of classes.
Yeah, so most often they'll ask you to pick this number. Some of you guys picked 4. Is that okay? Why not? Because it has to be at least up to 10. I didn't name any names, so there's no need to draw attention to yourself if you're one of those people. But now you know. It's got to be between 5 and 10. What's the Why say? That was neat. That was nice. I like old British comedy. All right. So this is the work that I must see. Don't say 10 because it worked really nice. No, it's not good enough. Because that's like you know it because it worked. Well, how did you set the things up before you knew what the class size was? This is how you do that, right? I like it. And then, say for example, I had a series of data that was 42, blah, 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 up to 128. And let's say you want to use 6 classes for whatever reason. What would the width be? 128 minus 42 divided by 6.
14.3 to 15.
Alright, so 14.3. And I feel really bad for the people that were using that number. Don't use the decimal number. Always round that up. Right? So what would my classes look like? If I do it by the book, it would look like 42. What would I put here? So my class width is 15. What would I put there? How wide are my classes? 15. 57, right? Because if they're 15 wide, then the next one better start at 57. And the next one better start at
72.
72.
102. 117.
And now these, maybe do you understand why I just can't put a 57 there? Because then where the hell would 57 go? So it's always just one below. So this is the book method. I'm catching up to the actual question. So it'll be one below, and then you just keep adding 15 also. You can do it, Jeff. Yeah. All right, stop there for a second. Now, if you want to do it the other way, the inequality way, what would this look like?
No, it's kind of about my quiz, but I got knocked points for. So the inequality way would be like 42 less than or equal to x, and then less than 57. And I'll talk to you later about my quiz, but
Okay.
you should have these points. That's fine.
I will find out. Is that cool? Is that all right?
Yeah.
Now, because if you write this, I'm not going to like that because that's not contained now. X is less than 42, or greater than 42, but also bigger than 57. It's not contained between them anymore, is it? And this says 42 is bigger than 57. That's neat. I don't know. That's weird. There.
When you write that for your history, like how do you write that for your history? You literally write
On the
that-
scale? Or this? Easy. All right. I like your look in the face. But here's, when you write the classes, that's how it looks.
Yeah.
Do you mean when you go to draw the picture?
Yeah.
Okay, this way I would just say 42, 57, blah, blah, blah. Which is another advantage this way has. This way, what would I have to do? 41.5, 56.5, 71.5. That's the boundaries versus the limits.
So my question earlier, like for the formula sheet, could we put like n is less than or equal to x less than?
Hell no. I'm sorry. Well, screw it. Hell no. I mean, because it's not really a formula. That's something I need you to know how to set up.
Okay.
Yeah. It's more like a format, not a formula. So definitely, if I see this kind of thing on your formula sheet, no, you got to know this. What's that for? Standard deviation. I love it. Right? That's somebody say, for this weird ass stat teacher I have right now. But this is the work going into calculating standard deviation.
So I'm just a little confused because in the homework for the classes, there was a problem where instead of having numbers, it had like, say it had seasons, like school.
Sure. Yeah.
How
So,
would you set that up?
what do you call this? What's the name of this finished thing? Whatever it would look like. What's the name? Histogram. And the thing I had to be more careful about on this is there should be no gaps. Which is why this does what it does. Where'd it go? I erased the damn. Here. That's why it does this. Because where does this class really end? 56.5. And where does this class really begin? 56.5. So there would be no gaps. Because if there's a gap, I'm saying there's a class with nothing in it. But if I have data that's not numeric, there's no scale to the seasons. So, then the gap won't mean shit. So if I put, here's fall, here's spring, am I like, no, who's missing? Well, nobody's missing, right? There's no scale to them. A gap doesn't mean something's missing. A gap just means I'm separating these independent things. Is that cool? I like it. So this would be a call to bar graph. Yeah.
Yeah, that's what I just wanted to make sure I did it.
Oh, yeah.
For classes, doing it your way, the next slide would begin with 57 still, right? Okay.
Yep. And then where does 57 go? Which class?
In the second one.
Totally, because it's equal to that, and this is not equal to that. So that's why, I understand, that's why some people don't want to do it this way, because you've always had a little trouble with inequalities, and you thought you escaped them. Well, then you can do it this way. And the trade-off is you got to deal with this. So either way you want to do it, I'm okay with it. As long as you do it right. Alright, so let's see, what else we got? Oh, I'll go here. Any other questions about histograms or stuff like that? What we're talking about? Yeah.
So over there, would you do 42 or would you do 41.5?
Where? Oh, here?
Yeah, but the other one right there says 42.
Totally. So, why does it say that? Because of what I said a second ago. If I put 56 and then 57, there would be a gap, wouldn't there? So this way has to go up and down by a half, so it artificially smooshes them together. Does that make sense?
Yeah.
This way, I don't have to artificially do shit because they already match, right? I can just let it naturally happen. Nothing artificial. I like it. Okay, cool. I like it. I had to give you the standard no answer at first. Because that's what happens. All right, anything else about histograms before we move into standard deviation stuff? Okay. All right, let's actually do a little tiny problem that we can do by hand real quick. So you have these. Sure. And I want to know the standard deviation for these. And you've got your formula sheet. Let me tell you, if you're not sure if it's a sample or a population, which one do you think you should assume it is? Sample, because most often in statistics we have a sample. If it's a population, I'm going to let everybody, holy shit, I got a population. This is a population. I have to be very specific and say this is a population. If you're like, I'm not sure, okay, it's a sample. It's got to be a sample because I'm not being like really in your face about it. That's what we normally have. With all that said, I'm still going to use the word sample like we did on the quiz, so look for that. So what's the formula that I'm going to use here then? S.
Summation
Minus x bar.
square.
And minus n.
Kick ass. And again, I don't make you memorize the formula, but you should remember what we talked about with each part of the formula. We squared because otherwise it is always 0. We add and divide by how many there are roughly because it's an average. That's n minus 1 because it's an adjustment for it being a sample. Right? You understand why everything's in that formula.
Can you explain the adjustment, please?
Oh, which one?
The adjustment, the n minus.
So this guy's got an n on the bottom, right? Got it. Become bigger. So very quickly, this row of, if I took their average age, would that be close to the actual average age of the class? Or let me say this again. If I took their average age, each of them would be closer to that average age than to the actual average age of the whole class. Does that make sense?
Yeah.
Or most likely that's what would happen. Because their average age is from them, so they're going to be closer to it on average. So when I calculate it for a sample, it's going to always be a little bit smaller than it's supposed to be, because it's going to be closer to the mean than it would be to the actual whole mean. So to do that, I just divide by a little bit less to make the answer a little bit more. It's a little adjustment. Now, why exactly is it n minus 1 and not n minus 2 or n minus 1.7? Well, that is some other math, right? But this is what turns out, and we also talked a little bit more about what this is. Who remembers what this was called? I always think about Braveheart. You can take away my calculator,
Oh, degrees of freedom.
but you can't take away my degrees of freedom. Sorry, it's just for me. It's just a joke for me. You don't have to learn. It's mine. Okay, cool. So, the way you look at this, to remember how to set this up, what do you need for this? What do I need to add up for this formula to work? What do I need to add up? Just cover that and say, I need a bunch of these. And that will remind you that you need, well, let me make one more here. These. So now once I get a bunch of these, I can then add them up and throw that number into the equation, right? So if you cover that up and say, I need a bunch of those, so I can add them up and put the number here. Okay, cool. So here's my stuff. Anybody, while we were talking, anybody think about doing the mean yet?
9.
What'd you get?
9.
9, okay. I did. I think said I did, but you said 9, okay. So you can double check, you can add those up. 40,
45 divided
20,
by
30, 45, yeah. I got you. Give me a second, I gotta catch it. So what's gonna be here then? -5. Now, does everybody see where that came from? And again, you can do this on your calculator. If you're not comfortable with your calculator, you know I'm going to give a slightly longer list, but not something insane. So you can still kind of do this by hand. You just got to be careful. The mean might be gross. You don't want to round the mean much at all. If you're doing it on the calculator, you don't have to round it. Just put 0.6666, whatever the hell it is. This will be, of course, -2. 0. 1. 6. So these are all the distances from the mean. You would think we could average these and get something, because that's what we want. Of course, when we add these all up, what do we get? 0. It's exactly 0 because they didn't round anywhere. Nice whole numbers. Let me stop there for a second. Okay, made. And then here, we square to kill the negative so we don't have to add the 0 thing happen, right? So we have 25.
4, 0, 1.
So when you add those, you get 66. Cool. Man, you guys are going to run me down. Y'all yawning on my shit. Yes?
I have a question. So for the formula sheet, can we put like L2 equals L1 minus something?
Sorry, buddy. If you want to use your calculator, you have to understand what to put where. But watch how this is. Where are these? L1. So if I have an X somewhere, I'm going to replace it with L1. That's just something I calculate. All right, so this would be L1 minus 9. And then this is everything that L2 squared. So you can kind of see it once you put the headings up there, what you're supposed to do in the calculator. And please, if you're taking the test and something weird is happening with your calculator, please, your God, come up and talk to me right then. Don't tell me after you turn it in, yeah, my calculator was spitting out alien language about halfway through the test, so I couldn't finish the last 4 problems. I'm like, oh, shit. Why didn't you tell me? Number one, I want to see that. That sounds cool. Number two, I want to fix it. Yes?
Do you have to use a calculator during the test, or do you use it?
You can actually just do this by hand. Yes. You might realize I'm going to give you a meaning that kind of is not 9. Maybe a little 11.454545 or something.
But instead of like putting it into like a list, can you just like do
I need to see this, for sure.
on the calculator?
No, you can just write this though.
Okay.
Yeah. Just like I just did. And then, so where's this go?
66 divided by
Good. It goes in, this whole thing is 66. Divided by